Hello and thank you for watching my videos. What you're looking at is a Greenstar heating only boiler made by Bosch, and this model is the FS79, and it's direct vent and it's done in PVC. On these smaller models you can do it in 2-inch, so we reduce right at the breech and drop it down to 2-inch using long sweeps, providing you're within the parameters of the tables that they give you in the book. This is a direct replacement boiler in a extremely confined space, nestled between another boiler and a water heater, so it was tight working quarters. The flue is pitched 1/4 inch per foot. And that's the flue. This is the intake right there, but behind it, the parallel pipe is actually the exhaust or flue. And so that's pitched 1/4 inch per foot, so that way any condensate, and these high efficiency boilers do produce quite a bit of condensate, so it all pitches back towards the boiler. And that condensate, since we're talking about condensate, is slightly acidic. So what they make us do typically is install a neutralizer where the condensate comes out. So that's where I have my neutralizer, and I made that neutralizer. So basically how I make it is with a very short piece of 2-inch PVC. I heat it up with a paint gun until the PVC is soft. Then I shove a bushing in each end, and out of the bushing I come up with an adapter. But prior to putting it in service, I fill it up with limestone, and that's how you get the neutralizing. And then that just goes right into a drain with all these other drains, so it condensates from other boilers. A lot of times we pump it to another drain, but in this application, this is one of the rare times where it can actually just drop it into a drain. So on the plumbing side, there's not a whole lot to talk about. We have our backflow preventer, existing water pipe coming down, and backflow preventer, pressure regulator that's adjustable. I use Calefi, and I also use Watts, but I think Calefi is a better product because you can set it at a higher pressure when you're purging it without having to worry about the relief valve blowing off when you're purging it. So you could set it at 25 pounds temporarily, purge the zone, and then drop it back down, to the 12 to 15 pounds. So have an isolation valve, and then we have an expansion tank right here. So what I use is a stop and waste ball valve on the expansion tank, and the reason I do that is because when these expansion tanks go, it's one thing to have a valve and it's convenient. However, even if you shut the valve off, you're still dealing with pressure. So this is a pressure vessel. No matter what you do, shutting that ball valve does not relieve the pressure. So by using a stop and waste ball valve, we can shut it off, then take the bleeder nut off to relieve the pressure, then change it. Much safer and much neater replacement. Staying on the hydronics, here we have 3 pipes. The blue one, the one with the blue sticker on it, is a return, a heating return. The red one is obviously the heating supply, and then our gas pipe in the middle. So this is our return, and I use the Webstone combination purge ball valves, and these are great. You just shut them off, and you're able to purge out each zone individually without having to add a teeth and a valve to do it. Here the gas was not a whole lot to do. It was basically, I swapped out a gas cock, that pipe above it was existing, and just did it with a few nipples and a union. Back on our hydronics, the heating supply comes up, tees off, picks up our auto feeder, pressure regulator, and a expansion tank, and then carries on to our air eliminator device, which is a spiral vent. Now, and then we move on to our circulators. So in this particular application, one circulator is for heating. You can see the orange light is on, so there's a heating call now. And the other one is for the indirect fired water heater zone. So it basically figures, it gets configured like a heating zone. What's great about this boiler is when you're using an indirect, a separate control is not needed. A separate zone controller is not required. So you can just basically plug the sensor in to the water heater that they give you with the boiler. They give you a thermistor style sensor and a separate terminal for the domestic hot water pump, the heating pump that is. And I use Webstone isolation valves on the circulators, so you can just isolate them, self-explanatory. Also, these circulators are relatively new. They're ECM circulators. They've been around for a couple of years now, and basically they use a fraction of the wattage as compared to the old 007s. So you're going to see more and more of these ECM motors, and I replaced all of mine in my own house with these. They're very energy efficient. So looking at the boiler, we have this front faceplate here, and this is actually a magnetic dropout. So this actually just sticks with a magnet all built into it. And you can take a look at the controls. Here on the left side, we have our dial which sets the heating water temperature, and different systems require different water temperatures. So right now we're almost near the max on this, and running, because we're using baseboard, and we're running around 190 degree water. On the left side we have our domestic hot water temperature, and right now we're at 125 degrees or so. That's where it's set for the indirect. And then this boiler comes with a pressure gauge, and also this is our temperature readout. So there's a lot of functionality with these controls that you need the manual for, because there's all different codes and different settings that are field adjustable. And I'm not going to get into that now, because I don't want Joe homeowner logging into his boiler because he watched my videos and changing all the settings that a plumber made. So if you don't know how to log into these, then you probably shouldn't be logging into them anyway. So looking inside this boiler, and basically what I did is this whole frame hinges on the bottom, and right there, and you pull the top out. So the top is a snap style mechanism right there. So you just kind of pull the top out, and then the bottom just lifts out. Very simple. So inside the boiler we have our gas valve, and this is our condensate trap, and here's our main boiler pump. Now all this pump does is pump to this built-in low-loss header, and what's great about this header is that it's set up ready to go as a low-loss header or just a regular primary supply and return. So if you're using it as the boiler as a regular supply and return application, you remove this plunger, and I've already done that. It's basically the first thing I do. It's in here. You take the cap off, obviously without the pressure and water on it, and you remove that plunger. Okay, so let's take a look inside the boiler and at the combustion chamber. So basically there's a screw right here that comes out, one single screw, and once this one single screw is removed, this whole door swings right open. Then behind that is this plate, and this has 4 screws, so these 4 screws get taken out, and that exposes the whole combustion chamber. So, and as you can see, we're burning right now with the flame sensor and ignition. And so servicing these, you remove these screws. Obviously it would be off, you can't do it when it's running. and it should only be done by a trained professional. And these burn very clean and are extremely efficient. They're 95% efficiency. Getting back to the rear of the boiler, in Massachusetts we have some special requirements regarding gas appliance, forced hot water boilers that are gas fired, and one of them is a low water cutoff, and that's what you're looking at right there. So that this boiler does not come with a low water cutoff. However, it comes with a connector in the back that receives this, so it's very simple to wire. But you would also need a transformer, a step down transformer, because the low water cutoff is low voltage 24 volts, and of course there's a pressure relief valve. We're also required to have a CO detector, and that's our CO detector right here. It's dual voltage, so it's battery powered and line voltage. Getting back to the flue piping, we are required also in Massachusetts to use a purple primer for the joints. But if you look, it doesn't look like I used it, because one of the things we're allowed to do is use a ultraviolet primer and then use an ultraviolet light, and you can see when I shine the light that I did in fact prime it. You can see how they glow. You can see every joint is primed, and that makes it a nice, neater job instead of having purple goop all over the place. And here's our boiler running right now. This is our air intake, and this is our exhaust, and you can see it running right now. It's in a tight alley, so there's not much I could do with it. And it was a direct replacement, so you can see there's 5 other ones here. And so also in Massachusetts we're required to have our gas vent sign, and the height of that is 7 feet off the ground. And so that's it, and thank you for watching my videos.